All right. Okay, so the first question asks for find the value of 7x plus 3y, and they give you what x and y are. So 7 times 12 plus 3 times negative 6. 7 12s, that's 84 minus 18 should give, what is that, 66? 66 for the first one. Second one then, find the value of, so you sub into a formula again here, a little bit more difficult with a square root. So it's 7 squared, u squared, times 25. Now, is this possible to do without the calculator? Yeah. Yes, it definitely is. It's a surd, so I can do this if I want. With my rules of surds, I can split them up. Because you remember, when you have surds, like something like square root 48, you can go square root 16 times square root 3. That's okay. So I can do it here as well. I can split up this multiplication of two things. The square and the square root here of the 7 is going to cancel. And we're going to have 7 and this times the square root of 25, which is just 5. So 7 times 5 is 35. Factorized in the next question. So we've got a few different types of factorizing. Recognizing the type of question is a good place to start. This one, not sure initially. Could it be difference of two squares? Maybe. This 4-term factorization, we should notice that that's grouping. This 2-term is definitely difference of two squares, because 81 is a square number, and 4y squared is also square, and this is our trinomial or quadratic. Okay, so let's get to this one. I'm going to think it's just common factor. So if I see what's common to both, I think AB is common to both, and then I'll have a little look what's left behind. 3a from the first one minus a b here, and I don't think I can do any more than that. That'd be 1 mark, or 2 marks, sorry, 2 marks for that. Next one is, this is 4 terms, so that's nearly always going to be grouping. So common in the first two, I look for what's common in the first two. M is common, so get 2n plus m. What's common in the second two is definitely a 3. The sign of which, I know if there's 2n here, gives the 6m, and an m here gives the 3m. What sign I pick here? I want it to be the same sign as here, so that's plus. So if I take out a negative 3, it'll work out for me. And then I need to do a final step. I need to put this and this are both times by this bracket, so I can write that. This and this together times by 2n plus m, like that. Yes, Caleb?
Does it matter if the n minus 3 is in front or behind the
No. This is difference of two squares, so you get 4y squared minus 81. That's 2y to be squared minus 9 to be squared. So recognizing that this is difference of two squares is key. How do I finish it then? I write 2y plus 9, 2y minus 9. Because this type of multiplication would cancel out the middle term, the y term. And the last one of these, the trinomial, t times t, 4 times 2 multiplied to give the 8. They both must be minus to make a minus 6t in the middle, and that's it. Okay, on to the next question, which is solving. So my first step here, multiply both sides by 3 to get rid of the denominator of 3. Peter, Dima, Lucas, Charlie, thank you. The 3's cancel here, so we're left with x minus 2 times 9. Add the 2 over to the other side and you get 11. Quite straightforward. This would cause a little trouble. When I multiply everything by 5, do I multiply this by 5 as well? Yes, I do, is the short answer. Everything must be multiplied by 5, because if I have an equation, I'll do a simple one. If I have something like this, and I multiply everything by 5, I get 5x plus 10 is equal to 35. and I try and solve it, I get 5x, subtract the 10 over, I get 25. X will be 5, which is the same answer as it would have been if I didn't. So I've got to multiply everything. Yes?
We have to simplify fully, right?
Simplify fully? If you can, yeah. Okay, so I multiply everything by 5, these terms, that, and that by 5. The only thing here is the 5 here and the 5 here will cancel each other out. So we are left with, actually, it's 15 times x, which is 15x. 15 times minus 4, which is minus 60. Plus x plus 2 is equal to 30 from the 5 times. If I gather like terms, 15x add a x is 16x. Negative 60 plus a 2 is negative 58 equals 30. And then I can add the 58 over here, and I get something. 88, is it?
Yeah.
And x is 88 divided by 16. What's 88 divided by 16? 11 over 2. Well, 16 fits into 85 times, isn't it? 5 times, and then a remainder of 8 over 16, which is a half. So 5.5 or 11 over 2 is okay, or 5.5 is okay if you use a calculator. Solve this one. I'm going to subtract 3f from both sides to start off with, because there's variables on both sides of the equal sign. And I get 6f plus 11 is equal to 23. Everything okay? Subtract 11 then from both sides. We get 6f is equal to 12. Divide by 6 both sides. F is equal, not 6, f is equal to 2. Okay, 2 marks for each of those. Moving along, make x the subject of this formula. Very classic GCSE question this. So I have 2y is equal to 5x minus 7. I'm going to add 7 to both sides, so I get 2y plus 7 is equal to 5x. Then I can divide both sides by the 5, and this all becomes over 5, and x is now isolated. So I get 2y plus 7 divided by 5. If you can see that. Okay, this one is a bit tricky as well. Make p the subject of this formula. First step, so I have a is equal to p plus p or t over 100. I notice there's 2 p's. If I see 2 of the variables I want, I know I'm going to have to factorize at some stage to get 1 down. I'll get rid of the 100 here first and say multiply everything by 100. I'd write 100a is equal to 100 p's and p or t not equals plus, oh I made a mess of that, plus. Then I have a p here and a p here, so I factor it out. P is equal to 100 and RT are factored out, and I have 100a over here. And then I can divide all of this over this side, divide both sides by it, and then it'll go away on the right-hand side. So my answer will be 100a divided by this bracket, 100 plus RT. These hundreds do not cancel. Otherwise, they would have cancelled at this stage as well, because they need to be in every term. Okay, we got simultaneous equations here with a fraction in it. Quite often a question as well in GCSE. I'm going to get rid of the fraction first. I just don't want to deal with it. So I'm going to multiply this line, this maybe a, you can say, by 2. I'm going to keep b the same. So a by 2 is going to give x minus 6y is equal to 18. Keep b the same for the moment and have a little look at what we got. I have these two. Yeah.
We're not sure it will try by 10 to make it,
Yeah, you could have. Yeah, I'm just doing this to have a little look. If you want to multiply by 5 next, yeah, or minus 5. So multiply a by minus 5 if you want next. I was going to multiply b, but that's okay. That gives minus 5x plus 30y and minus 5 times 18, I think 90 is it? Minus 90. And b I'm going to keep the same again. 5x plus y is equal to 28. Why have I done that? So these x's will cancel. Negative 5x, positive 5x will go away. I have 31y here, and negative 90 plus 28 is 62, I think, negative, because the 90 is negative, and y is negative 2. Once I know y is negative 2, I can sub it into either one, probably the second one because there's no fractions. 5x, now instead of plus y, it'll be minus 2 is equal to 28. And if you add the 2 over, you get 30, and x will be 6. All right, moving along. Simplify this. So this is like simplifying fractions. If I have a fraction 1/4 plus 2/5, and I wanted to add them together, I'd have a common denominator of 20 in the end, or 4 times 5, and I'd end up with 5 times that, 4 times that, and then if I add, I can add them. So you can do, if you can do that with fractions with numbers, you can also do it with fractions with variables in it. I'm going to do the same process here. For the denominator, I'm just going to, like I did here, 4 times 5, I'm just going to multiply them both together. That's the denominator. Multiply both these terms together. For the numerator, I'm going to do, well, if they're both over each other's denominator, I have to multiply the numerator by, so technically I've multiplied this by 2x plus 1 over 2x plus 1. I've multiplied that first one in order for it to be over 2x plus 1. Same way you multiply this by 5 over 5 to get the 5 over 20 here. Okay, so what am I doing? I'm really just multiplying the 3 by this denominator. I'll slow it down and write that. And then I'm multiplying the negative 2 by this denominator. So they both can be over the same number. I simplify down as much as I can. The denominator I don't need to change. I don't need to multiply it out. It's not necessary. It's pretty simple as it is. You could, yeah. 6x plus 3 minus 2x plus 2. If you multiply out the denominator, I'll give you that answer as well. X times x gives 2x squared. X times 1 gives x, and take away, so it gives negative x and minus 1. If you should know how to multiply out trinomials at this stage. And then on the numerator, I get 4x plus 5. Okay. Moving along. So we have a word problem here. Somebody buys 3.6 kilograms of potatoes and 2.8 kilograms of leeks. The total cost is that much. Leeks cost that much per kilogram. Okay. So you want to find the cost of potatoes. So 3.6 times the cost of potatoes plus 2.8, which is kilograms, times the cost of a kilogram of leeks is equal to a total cost of $13.72. So something like this would be a calculator question. So I'll use it. 2.8 times 2.65 is 7.42. So I'm solving this like an algebraic equation. 3.6 p's plus, so I subtract the 7.42 over here. It won't be negative, I've just done a shortcut there. 6.3 is 3.6 p's, and then divide by 3.6. My answer is going to be negative, but it's positive. $1.75. Okay. Moving swiftly along, we've got some sequences. This caused a few problems as well, I think. Find the second term of this sequence. So the first term would be if I subbed in 1 in for n here. The second term is if I sub in 2. That's what an nth term is. It gives you any term in a sequence by subbing in the number term it is. So the fifth term, you'd sub in 5 into the formula. You got to do the square first here. 2 squared is 4 times 4 is 16. Plus 2 plus 3, and that's 18 plus 3 is 21. So that's the second term of this sequence. Okay, find the value of n when the nth term is 498. So 4n squared plus n plus 3 is equal to 4 98. Something as difficult as this, possibly you could solve on a calculator, but you can solve it by factorization, which I didn't manage to do yesterday. If I subtract this over, I think I get minus 495. And we are looking at factors then that make 495. For something as difficult as this, you probably could use a calculator. Kalim? I know that one of the answers is a whole number. Has to be a whole number. The other one mightn't be, but it has to be because it's an n. It's a value of n, which has to be a whole number, because there's only whole number terms. Mireille, what was the answer again?
You didn't write an answer.
I didn't write it in the end. Oh, no. It's 11 times 45, yeah. I didn't write it, sorry. So I have 4n and n, and I think if we use 11 and 45, it does work out. Because that's 45n, and that's 44n in the middle two terms, which makes a positive n if this one's positive and this one's negative. I'm going to ignore this one, because that's going to give a decimal. And n is 11 from this one, knowing our null factor law. This one I can work out, but it's not going to be an answer. Only 11 is going to be an answer. If you wanted to do this on a calculator, you just draw this. So I'll show you how to do that as well. Clear anything out. I'm going to write 4x squared plus x minus 495. I'm going to graph that. Probably won't appear on my graph because I'm too zoomed in. Yes, I am. I'm going to go negative 20, 20 all around. I know it's more than that, but anyway. Okay. Whoa. Okay, so this is my graph. All I want to know is where it equals 0, so that point and that point. And I only care about this point. Why do I only care about this point? I know it's a whole number. Why also do I care about it? Because it's positive. Yes, that's the only one I care about, so I'd find that. Second trace, and that's a 0. Press enter on the left bound, go past it then, press enter on the right bound. Press enter a third time and you get 11 for the 0. Okay, that was a little bit tricky. Well, I thought it'd be easier to factorize. It's not. Anyway, find the nth term of each sequence here. So I'd always look at the differences. So subtract 2, sorry. Subtract 2, subtract 2, subtract 2. How do I form that? This is the linear sequence then. The first difference is different. So the nth term would be, well, whatever this difference is, minus 2n. That's multiplied by n because it's a repeat subtraction. It's a multiplication. Priyanka? Yeah, you can, yeah. What's a plus or minus?
Oh, it's plus 6.
Okay, and the way to find that is to, if I go back another term, I would find out where the 0 term was, and that's 6, if you want to do that. So I go back one from the sequence, fine. Yeah. 6 is same. 6 minus 2n is the exact same answer, yeah. It does look a little bit neater, yeah. Starting with a negative. It's not wonderful. Okay, this next one then, I'm looking at this sequence. That's plus 3. That's plus 6. That's plus 12. I look at the difference of the difference. That's plus 3. That's plus 6. Uh-oh. That's going to happen again, isn't it? Or is it? Yeah. That's going to keep happening. So if I suspect that that's going to keep happening, what type of sequence is it? Geometric. It's geometric, yes. So that means it's a division one. So 6, to find the ratio, 6 divided by 3. So it's a multiplication. What's the multiplication? 2. It's multiplied by 2. So if it's multiplied by 2, what's the nth term? Or the first term times the ratio to the power of n minus 1. So remember, it's first term of the sequence times the ratio to the power of n minus 1, always, with this geometric. First term multiplied by the ratio, power n minus 1. Dima? Okay? Yeah. All right, what about this one? Is this geometric? Which one?
Yeah, it's geometric. U times by half.
What's a quarter times by a half? Right. Right. So what is it? Anyone figure this one out? No? Okay. Well, let's just look at the difference. How do I get the difference between these two? I have to subtract. What's I subtract a quarter, don't I? If I have a half, which is 2 over 4, maybe if you found a common denominator between all numbers, would that be an idea? What's the common denominator between 2, 4, 6, 8, and 10?
2. Or 1. 10.
Common denominator.
It's 80.
Ah.
80. Or like 40.
Does 6 go into 40?
80. Oh no, 6.
Does 6 go into 80? No. It's going to be like 240 or something. 24 works for all these, and maybe 10, 240. You could do that if you wanted to. And we'll look at that in a second. Or maybe you look at that straight away. If you have them all over 240, maybe you'll see a common denominator. Or a common pattern. Over 240 and over 240. So I need to convert them all. A half is not too bad. That's 120. What's a quarter over 240? 60, I think, isn't it? 1/6 of 240 is 240 divided by 6, which is 40. 1/8, 30. 1/10, 24, yeah. Okay. What type of sequence is this?
I don't know, man.
I don't know, man. Okay. Oh, well, let's go back to without doing the common denominator. A half. So it's a difference of a quarter. What would it be if you thought it was geometric, like you thought it was, Ozzy? How would I find it?
Well, it was wrong. So I don't know.
All right, but how do you do it? How would you find the ratio if it's geometric? It's the second term divided by the first term. So let's pick, this was our geometric sequence before, 3, 6, 12, 24. So 24 divided by 12 gave 2. 12 divided by 6 gave 2. 6 divided by 3 gave 2. So if I do the same here, a quarter divided by a half, what's that? This is all rough work over here, really. What's a quarter divided by a half?
2 over 4.
You can keep change flip. 2 over 1, which is 2 over 4, which is a half. But the ratio must be consistent, so I'll try a second one. What's, yeah, no? If I do the same thing here, a sixth divided by a quarter, I have to get the same answer for it to be geometric. It's not going to be. 1/6 multiplied by 4 over 1 is 2/3, or 4 over 6. It's not the same. Okay, so let's look at this sequence. What's the difference here?
40 to 40, that's 0. There's no difference.
And that's 120, or 60 over 120.
Oh.
60 over 240. What's the difference here? 20. What's the difference here? 10. What's the difference here? It's geometric. What's the ratio? Six. That's the first difference. What's the second difference? 60 down to 20, 40. 20 down to 10, 10. 4. Third difference, 30. Okay, also not working.
Sure, maybe it's just linear. It's just nothing.
It's just nothing?
It's not a sequence.
Linear would be first difference.
What did you say? Did you say this is a very difficult question?
Why is this not in the last question?
Would you say this is a
Oh,
very
no.
difficult question?
No,
No?
no.
It's light work there, man. Light work.
Did anyone come up with a formula? What's consistent with the top, with the numerators? It's always what? What's the formula for the denominator? 2, 4, 6, 8, 10. That's what type of sequence?
Oh, is it like 2n? Like
That's a linear sequence. That's a linear sequence.
2n to the power of -1.
1 over 2n. The linear sequence is here. It's only looking at the denominators. So you just go 1 over. So 2 to 4 to 6 to 8 is adding 2 each time. So what's a repeated addition of 2? That's multiplication of 2. So 2n. And do I need a constant term? Well, if I went back 1, it'd be 1 over 0. So that's 0. So it's just 1 over 2n.
So what is it?
It's neither. It's none.
Wait, Mr. Collins?
It's more linear than anything, but it wouldn't be linear. It's like an inverse. Yeah.
It's a weird question, but if I did 2n to the power of -1, would it be the same answer?
Yeah.
If you have fractions, will it like always be
2n to the power -1. 2n to the power. Yeah, would you? Yeah. Yeah, it's good. Yeah, well done. Okay. So it's kind of like a sequence of its own.
will we get like questions like this on the test?
Maybe in paper 6. In the test, I'll stick to just cubic, geometric, linear, and quadratic. No, I'm not gonna. Yeah, okay. I know.
Put that question and question 8, the second one where we have to find where the end of this board.
Oh yes. Sorry. Okay. Proportion. Y is inversely proportional to x squared. So how do I start that off? Y is proportional to the inverse. Right, like. Which is y is equal to k over x squared. Yes, so I set up this thing, some multiplier over x squared. Now I have my initial statement here of y is 7.5 when x is 4. So I put those in, those initial conditions. And then I find what k is. What's k from this? It's 16 times 7.5.
Yeah, 120. It's 120.
Which is 8 times 15, which is 120. So k is 120. This is not my answer. I now need to use this. Y is equal to, I know what k is, 120 over x squared. When x is 5, I put in 5 here. Y is 120 over 5 squared, which is 25. I'll move my hand. And then I need to simplify that fraction as much as I can. So 5 fits into the numerator and the denominator. 5 into 120 is, I'm drawing a blank, 24 is it? 24? 24 over 5. Or some fraction like that. What's that? 4 and 4/5? For this one, no calculator, no. Don't think you need a calculator. Y is directly proportional to the, so these are two difficult, I think the ones in the exam are a little bit easier than this, if I remember. Directly proportional to the cube roots, you got cube roots now, but y is proportional to the cube root of x plus 3, with a little 3 there. So that means y is equal to k times the cube root of x plus 3. I use that, and this conditions are 2/3 is equal to k times, all right, 5 goes in for here. 5 plus 3, that's 8. The cube root of 8 is 2. So I'll just finish it over here. 2/3 is equal to 2k, because it's the cube root of 8. Divide by 2 over here, I get 2 over 6, and k is 1/3. That's tricky. K is 1/3. So let's rewrite this with k as 1/3. Y is equal to 1/3 of the cube root of x plus 3. Now I can put in my 24. Y is equal to 1/3 the cube root of 27, I think. 24 plus 3. Cube root 27 is 3. So and then it becomes y is 1/3 times 3, which of course is just 1. And y is, after all that, y is 1. Okay. We got an inequality next. Find the integer values of n, so values that satisfy this. Yeah. Positive or negative whole number. Okay, so there's going to be whole number values of n. Anybody have a strategy here? Split it up. I like to split it up too. I'm going to split this bit up to find the lower bounds and this to find the higher bounds. So use 6n as the middle point. I'm going to do this first, the left-hand side, and then afterwards I'll do the right-hand side. And I'll combine those answers then to find what n is. All right, Lizzie? I'm going to add the 2n over here to get, not equal to, get equal 8 n's. So n is 18 divided by 8, which as a 8 fits into that twice, and 2 1/4. Yeah. Okay, that's one answer. This one, subtract the n over again. I get 5n is less than or equal to 30. N is less than or equal to 6. Okay, there's my bounds. Find the integer values for which satisfies n. So n can be, what can it be? 6, definitely. 6, 5, 4, 3. Yes, exactly. Or 3, 4, 5, and 6. Why am I doing that? Why am I not saying 2 1/4 up to 6? Because it says it's integer, so that's whole numbers. Can't be 2 1/4. It's got to be the next number bigger than that, which is 3. 4 is the next integer, 5, and it can be 6 because it's less than or equal to 6. Yes, Kaylee. I subtracted the n over here. Subtract n from both sides. Anissa? No. So this is 3 marks. You might, if you've done this out and just wrote 3, you probably get 2 out of the 3 marks. Find integer values for n. So values. Yeah, but they're integers, so they're whole numbers. So yeah. 3. That's the answer. This is the answer. 3, 4, 5, 6. They're all the values for n that makes that true. Any other values will not make it true. Okay, I think we're on to the last page, the graph, the region. So for these 3, I'm going to look at x equal to 0 to draw y equals to 3, and 2x plus 3y is equal to 12 first.
Wait, it doesn't show that on the sheet.
Yeah. Okay, so I look at drawing those lines before I do any inequalities. X equal to 0 is here. Where is it? Here. That's the y-axis is x equal to 0. Yes. That's where x is 0. Where's x greater than 0?
I mean, to the right.
Over this side, yeah. So I put in these little arrows. I don't shade yet. You can shade if you want. The wrong side. Some people shade the wrong side here, so you're left with a bit. So I'll do that as well. Shade the wrong side. Okay, very good. Y is greater than 3. So this is the line y equals 3. That's that line drawn. That line. Where is y greater than 3? This side, yeah. So you can shade all this is wrong then. It depends on the question. It might ask you to shade. It asks you just to find the region. So you can do either side. It's easier to shade the wrong side in this case because it just leaves a clean region in the middle rather than triple shading. And then the last one is the hardest one to do. First of all, I have to be able to draw this line. Isn't that right, Peter? Have to be able to draw this line. Yeah. Let x equal to 0, and we'll find where it crosses the y-axis. So if x is 0, we get 3y is equal to 12, because that turns to 0. So y is 4. So it crosses at 0, 4. That's up here. Now I need to find where it crosses the x-axis as well, so I let y equal to 0. And I get 2x is equal to 12, and x is equal to 6. So here is where it crosses the x-axis. I combine those two together with a ruler.
Wait, so why does y equal 4 again?
Yeah. I find out where it crosses the y-axis by letting x equal 0, because I'm going to find the point along here. Okay. And then I draw the line. So there's two options here for my region. It's either all this large area up here or this tiny bit here. So 2x plus 3y is greater than 12. How do I figure out what side of the line it is? I test the point. I'm going to test 0, 0 to see is 0, 0, this point, on the correct side or the wrong side. So I'll test it using the inequality. 2 times 0, so I'm subbing in here, plus 3 times 0, and now I look at the inequality. It was greater than less than 12. So no, that's not right. That's wrong. That means it's on not the side I want. So the arrow will point away from it. Or I can shade this little bit. So this is the area. This area up here. So region or something like that, if you want to put it's unshaded. And that's the final question. It'll be, the actual question will be better written than that in the exam, if it is a region. It'll say mark the region with the letter or something like that. I cut out that bit of the question. Okay.